Pythagorean Theorem. Anybody know what the Pythagorean Theorem is before we get started, besides reading it? What is it, Elena?
A squared plus B squared equals C squared.
Okay, a squared plus b squared equals c squared. Raise your hand if you've heard that before. A squared plus b squared equals c squared. At some point you've heard that, whether a YouTube video, on Facebook, or whatever. Hey, why do you got that out right now? Okay, you don't need that. Put it away. All right. Okay, Pythagorean Theorem. We're going to use Pythagorean Theorem when we have a right triangle. So you see that definition there says, if a triangle is a right triangle, then the square of the measure of the hypotenuse is equal to the sum of the squares of the measures of the legs. Wow, that sounds exciting. So let's look at this a little bit more. We're going to use the Pythagorean Theorem when we have a right triangle. So if I were you, I would circle this word right triangle, because you're only going to use this when you have a right triangle. The Pythagorean Theorem deals with side measurements. So when it says here, we use it to find the measure of a side of a right triangle, we're using the Pythagorean Theorem for sides, not for angles. All right, so in this lesson, we're not going to deal anything with angles at all, just sides of right triangles. Okay, so the Pythagorean Theorem deals with a triangle, and each side of the triangle has a special name. So we're going to call the side that is across from the right angle is always going to be called the what? Do you guys remember? We talked about it a little bit the other day. Hypotenuse. Okay, so this is, this side is called the hypotenuse. And I'm spelling it for you so you can make sure you spell it correctly on your paper. The hypotenuse is always this letter C. It's always across from the right angle. Always. So sometimes students need to draw an arrow line across so that they can remember which one is which. Then the other two sides are just called legs. They don't have any fancy names. This is a leg and this is a leg. So the only one that's fancy is the hypotenuse. It's always across from the right angle, okay? Now, what this formula up there said is exactly this. If you take the hypotenuse and you square it, you should equal the two legs squared and then added together. That's what this means. And we're going to do some examples so you're going to be just fine. Now, typically, when you guys said, yeah, you knew what the Pythagorean Theorem was, you said a squared plus b squared equals c squared. This right here says c squared equals a squared plus b squared. I want you to try to remember it as this with c squared first, because of the fact that we're going to do some other things in which we need to make sure that the c is first. All right, so for the sake of this lesson and the way that I'm teaching it, I want you to put the c squared first. All right, so let's do a couple examples here. If I have a rectangle, let's remember our formula is c squared equals a squared plus b squared. So I'm going to go ahead and write that down at the top of the page. I'm sorry, at the top of where my example is. So I'm going to say here is c squared equals a squared plus b squared. So which one is the c value? It looks like 91. This is interesting. Look, I have this triangle here that's a right triangle, but I don't know how much this side is, or do I? Do we know how much that side is? I have a rectangle, right? And what do you know about a rectangle? What do you know about opposite sides in a rectangle? They're the same. Good. So if the bottom part is 9, what does this mean this circle part is? Also 9. So let's go ahead and write that in. Okay, now which one is the hypotenuse? Square root of 91, right? And again, if you didn't know, you can always draw a cross from the right angle. So across from the right angle is my c squared. So I'm going to put the square root of 91 squared equals, does it matter which one is A and B, you think? It doesn't. They're just the two legs. The only one that matters is C. So I can say x squared plus 9 squared. Okay, so now let's go ahead and solve this out. Let's do the right side. X squared, what is 9 squared? 81. So I have 81. What is the square root of 91 squared? Have we done that? It's just 91. You're exactly right. Anytime you square a square root, these cancel each other out. And so you just have 91 left here. Now, how would we solve this for x? Get x squared by itself, so we're going to subtract 81. So it gives me 10 equals x squared. We know how to do this now. Square root, square root. Does the square root of 10 break down? I would say just, it does 2 and 5, right? But if you do 2 and 5, you don't have any pairs, right? So you can't make it any smaller. So x is equal to just the square root of 10. That's it. Questions on A? Okay, let's look at B. First thing I would always do is identify your hypotenuse. Which one is my hypotenuse here? 6. Excellent. So I'm going to put a C there because I know that that's my hypotenuse. I'm going to write it down, my formula. Please write your formula down so that you're getting in the habit of putting c squared first. The major mistake that students make in this lesson is mixing up the c. That's like the only mistake that's made here. All right, so just make sure you know which one is c. So now let's go ahead and fill in our numbers. 6 squared, n squared plus 4 squared. See if you can solve this out. I'll do it while you do it on your paper. Are we just going to leave the square root of 20 alone? What should we do with it? Break it apart, right? So I have a pair of 2's. So I can write this as n equals 2 radical 5. Questions on that? Okay, there really isn't more to this. Okay, like this really is it for the Pythagorean theorem. Plugging numbers into an equation. Okay, and then breaking down the radical. Like I said, this is a pretty simple lesson. So let's take it a step further, just one more step, and let's talk about how can we tell if something is a right triangle or not just by looking at the sides. Okay, so it says you can verify a triangle is a right triangle by substituting values into the Pythagorean theorem. So if I give you a bunch of side measurements and I tell you, or I ask you, is this a right triangle or not? If this is a right triangle, then that means that when I solve this out, my c squared is going to equal a squared plus b squared. So when I solve this problem out, the sides will equal each other. So let's check letter C. Which one's my biggest here? 12. So this is going to be my C value. And I'm going to set it up like this. C squared, and then I'm going to draw a circle because I don't know if it's equal to, greater than, or less than, I don't know. a squared plus b squared. Okay, remember that circle means I just don't know if it's equal to, I don't know if it's less than, I don't know. So if we plug our numbers in, we said 12 was the biggest, so 12 is going to be my c value. Okay, go ahead and solve it out. You all have calculators, or you should. If not, grab your calculator, please. Chris, do you have a calculator? And then 25 plus 121 is 146. Is that what you guys are getting? Okay, is 141 equal to 146? No, so this is not a right triangle. All right? We know that when we squared the c side, we got 144, and this is smaller than 146. So if the c squared comes out to be smaller than a squared plus b squared, this is an acute triangle. And so over here in our box, we're going to put less than sign for the acute. So if you get c squared to be less than a squared plus b squared, then it's an acute triangle. So then what do you think obtuse is? Greater than. Good. So if you get your c squared to be greater than a squared plus b squared, it's an obtuse triangle. Okay, so let's look at example D. What's the problem with D? Okay, why is 5 radical 6 a problem? It's confusing. Okay, what else? You already got to square some things, right? But in order for me to get started, I have to know which side is actually the biggest. And if I don't know what 5 radical 6 is, I don't know if it's the c value or not. So in your calculator, we're going to get a decimal value. 5 radical 6 really means 5 times radical 6. So in your calculator, I want you to do 5 times the square root of 6. And let's get a decimal value for that. 5 times the square root of 6. 12.2? Is that what you guys are getting? Okay, so what I'd like you to do is right above 5 radical 6, let's write 12.2. Just so that we know which one is going to be the biggest. Now when we plug it in to our equation, we're not going to plug in the decimal. The only reason we need the decimal is to figure out which one is actually the c value. So in this example, which one is the c value? 5 radical 6, right? This is going to be my c, because it's the biggest of the 3 numbers. Okay, so let's go ahead and set up our equation. C squared, we don't know what the sign is, a squared plus b squared. Okay, so then I have 5 radical 6 squared. 4 squared plus 11 squared. Go ahead and take care of the right side of the problem with your calculator. What is 16 plus 121? 137? Okay, now the question is, how do we do 5 radical 6 times 5 radical 6? What I'd like you to do is, go ahead. Let's multiply 5 radical 6, let's write this out, times 5 radical 6. I want you to write this out like this so that you know how to do this when it comes to your homework. What's the rule when multiplying radicals? Outside times outside, inside times inside, right? That's the rule. So outside times outside, 5 times 5 is what? Okay, so I get 25 times whatever was on the inside. So the square root of 36, right? So I did inside with inside. Gives me the square root of 36. But what is the square root of 36? 6. So I know that this just becomes 6. And then I need to multiply 6 times what? 25. And 6 times 25 is 150, is that correct? Yes. Okay, so I have 150 something 137. What do we know about 150 in comparison to 137? Excellent. It's greater than. So if this is greater than, what kind of a triangle is this? Perfect. Put your symbol there too for obtuse triangle, please. Okay, any questions on this first page? Okay, let's flip it over to the back. One of the things about geometry and algebra 2 both is you're going to do a lot of story problems. You're not going to get away from them. So just accept it. All right? Sorry, that's how it is. Because now that you know the skill, do you know how to interpret it? Do you know how to actually apply it to your life? Why is math ever important? Here you go. Okay? This is why. So if you're a construction worker, you have 6 feet of a post that is above ground. How far is the top of the post from a point 5 feet away from the foot of the post? If I read that and try to set up an equation without a diagram, I'm about 99% sure I'm going to get it wrong. Okay? So this always draw a diagram thing right here, huge. Always draw a diagram. Every single time. A picture is worth 1,000 words, not just in real life, but also in math. Okay? All right, so let's do this. I'm going to help you. We're going to do some together so that you get in the hang of drawing a picture. We have a 6-foot post above ground. There we go. A 6-foot post. I'm not asking you to be not Mozart. That's music. Who's? Picasso. Thank you. Or Leonardo da Vinci. Which, has anyone ever seen the Mona Lisa? It's pretty weird looking. Okay. All right, so we have a post that's 6 feet above ground. How far is the top of the post from a point that is 5 feet away from the foot? So 5 feet away from the foot, I have a point. And I know that that's 5 feet away from the foot of the post. That means the base of the post. Remember, every single time you're trying to draw a right triangle. That's what we're dealing with. Okay, so let's connect this. Put your right angle in there. This is what you're trying to find. You're trying to find the hypotenuse. It says, how far is the top of the post to a point 5 feet away? Okay, so now can you use c squared equals a squared plus b squared? You can. What's the c value? X. All right, why don't you go ahead and set this up? Find a value for x, please. Oh, it should be 61, huh? Is that what you just said? 61? Oh, boy. Now, if I asked you to run the square root of 61 feet, does that make sense to you? Please, go take a jog, square root of 161 times. What is that?
Sense to me.
Makes sense to you. Perfect. Okay, so instead of that, when we're doing story problems, I want you to give me an answer that makes sense. So the square root of 61 does not make sense here. What would make sense? A decimal value would make sense, right? So on your calculator, I want you to figure out what is the square root of 61. And on this one, you're going to hit the change. Yep.
But then I get 8.
Change it again.
But then I get 61.
So why don't you grab a graphing calculator? You should have number 9 on your graphing calculator. Look, it's up there, sitting there waiting for you. What'd you guys get? 7.8. So here's what I need you to write. These little squiggly lines in math mean approximately. That means you are telling me that you have rounded something. So 7.8. Now, the other part of story problems is that you're not just going to be able to find the answer. You have to interpret what this means. Okay, so what does it mean, 7.8, in response to my problem? Okay, so this is what I'm looking for. The question asked, how far is the top of the post? Your answer should be, the top of the post is 7.8 feet, but we're going to use the word approximately. And everyone is going to do this. I get that this is not English class, but this is part of your geometry education. The top of the post is approximately, sorry, in the way, is approximately 7.8 feet from what? From the point on the ground. This sentence is what will get you full credit. All right? So we're doing full sentences now in geometry because it's great that you can plug it in and find an answer, but do you know how to interpret your answer, what your answer means? Okay? Okay, example F. What is the longest straight line that can be drawn on a floor which is 10 foot by 4 foot? Oops. 10 meters by, I'm sorry, not 4 foot. 10 meters by 4 meters. Okay, if we have a floor that's 10 by 4, aren't they telling you that it is a square or a rectangle, right? So we're going to do a floor that is 10 feet by 4 feet. And you can go ahead and make this a rectangle if you want to. What is the longest straight line that can be drawn on a floor? What line are we talking about? The hypotenuse, but I don't have a hypotenuse. Those of you that do construction or carpentry, what's the longest straight line in a rectangle? I'm looking for a word that starts with a D. Yes, the diagonal. All right, so the longest straight line is going to be the diagonal. So we're going to draw a diagonal in this. We'll call that X. My right angle is down here. So now you've created a right triangle, which is what you need every single time. Go ahead and set up your equation.
You do.
You can't put your hand on it. You put it down. Yep. You press hard. once you think you have your answer, okay, remember, we're trying to interpret our answer. And if I tell you that the longest straight line is the square root of 15 or whatever, that doesn't make sense, right?
How do you erase it?
You just push this undo button. Tap this undo. There. And one more time. There you go. Okay, so once you think you have an answer, go ahead and write a sentence with your answer. Now, I have a difference in rounding. This is interesting. Some of you have rounded differently, so we're going to talk about rounding in just a second. Okay, now you can use your calculator. Okay, we're getting 10.77. Are you guys getting 10.77? Mm-hmm. Okay, 10.77. If we're going to round 10.77, uh-oh, that's all right. 10.77. If I'm going to cut it off here, is this number big enough to change this?
Yes.
Yes. So you should change it to be 10.8 if you're going to cut it off there. Okay, so the longest straight line is it's approximately, you need to put that word approximately in there, 10.8 feet. Good. Meters, 10.8 meters. Excellent. Thank you. Okay? Questions on that one? All right, let's go to letter G. It's almost time for break. You're fine. Okay, it says an umbrella that is 2.5 feet long is packed diagonally into a suitcase. If the case is 1.75 feet wide, how long must the suitcase be? Yes, you need to draw a suitcase. Just draw a rectangle. Everyone's drawing. Here's my suitcase. An umbrella that is 2.5 feet long is packed diagonally into a suitcase. So I have an umbrella that is packed diagonally into a suitcase. So that means my umbrella is here. Beautiful, isn't it? And I know that this is 2.5. It says the case is 1.75 feet wide. So whether you put your 1.7 on the side or on the bottom, it doesn't matter. You should still get the same answer. We have a right angle here. And can you guys see the right triangle that we've created here? Okay. How long must the suitcase be? So I'm trying to find out this down here on the bottom. Okay, so again, we're going to use our c squared equals a squared plus b squared. What's the c value in this problem? Across from your right angle. Okay, so across from the right angle is the c value, so 2.5 squared equals 1.75 squared plus x squared. Please check your paper and make sure that you have x in the correct spot. Okay, now we're just going to rely on our calculator. 2.5 squared What's 1.75 squared? Someone besides Dakota. 306? Was there a decimal in there anywhere? Is my math right? Someone check it. Is that what you guys are getting? What's 1.75 squared? Is it 3.06? Okay, and so then I subtract 3.06. I should get 3.19. And then what is the square root of 3.19? 1.78. Anyone agree with that? Y'all are quiet. Does anyone agree with that?
Yes.
Thank you. X equals 1.78 approximately. Or is that the exact decimal? It's approximate? Okay, so we did some rounding. Okay, so what's this sentence going to be? Great. Aaliyah, what's the sentence going to be? What are you trying to find? How long the suitcase is, and what answer did we get? So what are you going to say? Perfect. Except we would use the word long, but yes, you're right. So the suitcase is 1.78 feet long. Okay? Questions on that? All right, let's take a break until 11. So it's 10:45, be back at 11. We're going to finish these notes up at 11. I'm going to try to start right back at 11, okay? All right, letter H. If you travel 25 miles east and 15 miles south, how far are you from your starting point? First of all, we need to know our directions, right? So I don't remember what these things are called. A weather vane, is that right? North, south, east, west. Is that what they are called? Is a weather vane? Colt? Oh, poor guy. He worked third shift. You're hard to wake up. Okay, little cat nap. Okay, here we go. So if you travel 25 miles east. All right, so I'm going to travel 25 miles east. So I'm going to go this way for 25 miles. And then I'm going to come down 15 miles south. How far are you from your starting point? Well, again, what are we trying to create in every single problem? A right triangle, right? So it would make common sense to pull this down and make it a right triangle. And how far are you from your starting point? That's going to be this over here. Please sit up. Thank you. Okay, so now that my triangle is upside down, that doesn't matter. What's my C value here? It still is X, right? Across from the right angle is still going to be my C value. So C squared equals A squared plus B squared. Okay, go ahead and figure it out on your calculator. You guys getting the square root of 850? Okay, what is that as a decimal value approximately? 29 point what? 29.2. Okay, so we can do the approximately 29.2. So who wants to tell me what the sentence should be? Okay, let me give you a clue. Here's a little English lesson. When you're writing the answer to a story problem, you need to look at what is the last part of the question. That's how you're going to start your sentence. You are 29.2 miles east, or I'm sorry, we don't have a direction. 29.2 miles away from the starting point. Approximately, excellent. Thank you for the reminder. You are approximately 29.2 miles from the starting point. That's what should go there. All right, letter I is a great question. I would maybe star this something. You see this question come up a lot when you're dealing with right triangles. If a ladder 8 feet long is placed so that it just reaches a window 6 feet from the ground, how far from the building is the foot of the ladder? Again, that seems a little bit hectic. Okay, so we have a window that is 6 feet from the ground. Here's my window in my house. There is a ladder that is up against the house. Now, some people want to draw the ladder straight up and down like this. If you put a ladder straight up and down against the house, what's going to happen? Okay, so instead of my ladder being there, my ladder should be leaning against the house, right? Your ladder is leaning against the house. And it says the ladder is 8 feet long. And if you want to make a ladder, that's fine. How far from the building is the foot of the ladder? How far from the building is the foot of the ladder? That's what I'm looking for here. And so my right angle is down here in the corner, which means my C value is what? 8. Excellent. All right, so I have C squared equals A squared plus B squared. What is the C value? 8. It's 8, right? So that means we're just going to have to do a little bit more work. Is it 28?
Yes.
Okay. What's the square root of 28? 9.3? 5.3. Anybody else agree with 5.3? Okay, but it's approximately, I'm assuming, right? 5.3. Okay, so then if we're going to write our sentence, remember we're going to look at the last part of the question. How far from the building is the foot of the ladder?
The foot of the ladder is 5.3 feet.
Say that a little bit louder.
The foot of the ladder is 5.3 feet away from
The building. Okay, so the foot of the ladder is approximately 5.3 feet away from the building. Excellent. Okay, how do you guys feel about this? Stick up your hand with the number 1 to 5. 1 is, wow, I have no idea what we're doing. And 5 is, I'm a rock star. Quickly, let me see it. 1 to 5. 5, I'm a rock star. 1, I have no idea what we're doing. Woo. What's your number? Ladies, what's your number? How confident do you feel? 5 is great. 1 is, I have no idea what I'm doing. Good. All right. No 2s or 1s. We're good. Did you say 1? That's right, you better be just playing. Okay,